Okay, so can you all hear me? Okay. The High Assurance Software Engineering, or HASE plan, is something we've put together to try and address some of the concerns around building assurance into the product. And Brandon is the penetration test lead on our team, and I'm the test manager for the product. And brief agenda, we're going to dive into just a few slides giving you an overview of what we're trying to accomplish with HASE and some of the goals there. Then I'll list just a few questions I want to have all of you keep in mind while we're going through the rest of the slides. And the remainder of the talk will be a drill down into the various elements that we've put into place for high assurance for the HASE process. And at the end, we'll do some Q&A. If you have questions throughout, certainly feel free to voice them at the time you've got them. So there's a set of goals we have for Unity that have led us to build this process. So the first one is to bridge between what has been kind of traditional loose Microsoft processes, somewhere between that and the other end of the spectrum being the defense security sector, which has done a lot of work over many years on developing high security, high assurance, but for very limited aspects. We want to produce some well understood, verifiable code. Marcus talked a little earlier about ensuring that the specifications are very clear, particularly for all of the critical components. We've heard a little bit about using the componentization effort, reducing the attack surface, trying to contain flaws through an approach of layering the system. We also want to reduce the exploits and provide assurance kind of in a stepping stone foundation so that if we move into this space of providing MLS on top of the Unity platform, for instance, that we've put in place enough assurance such that that is possible, if not in V1, then in a future version. And to build general credibility among experts that the assurance that we're putting into the process is building a system that's deployable for the critical security infrastructure, financial and banking, as well as for home use and securing your own personal data in these red-green partitions, for instance. So we've put together a cross-discipline team. Brandon, Christine Chu is one of our program managers. Simon McMahon is a new program manager, just joined the team and is going to be dedicated just to the HASE effort. Marcus, who you heard talk earlier, is one of the architects for the project. Mike Marr is a developer, a longtime Microsoft senior developer who's focused solely on high assurance development, and myself as the test manager. We felt it was key to really have a cross-discipline team to ensure that all aspects of the development lifecycle are really taking into account the processes, architecture, program management, development, and testing. And so we've built a team around that. And then there's a set of supporting people who are involved in a lot of the critical decisions, but haven't been as involved in the actual design of the HASE process and the rollout of the process to the team. Yep.
People who've operated secure government systems as ongoing day-to-day members of the government?
Yeah, I think so. Well,
Brandon,
we have one in myself that has experience in the government and high assurance and intelligence community. Yeah.
And certainly we've also relied, I haven't shown them on this slide as direct members of the team, but we've relied on a lot of the other expertise we have inside Microsoft as well. People like Steve Butler, Dave Locksmith, to provide review and input into both the design as well as into the HASE process. Oops, going the wrong way. So how did we get here? We took a look at a lot of the work that's been out, as I say, mostly in the defense sector with the old Orange Book, TCAAB, specifications, common criteria, talking with the folks on our own team who have been instrumental in the past in building some of these high security systems, as well as reviewing a lot of the published reports that are out there, many by members of the people on this board, and trying to take the best practices essentially from all of those things to build up a process that we felt would allow us to extend assurance in both. This is something, speaking historically, that we started with the Palladium NGSCB efforts and are moving forward into the Unity efforts to extend assurance. We've also taken a look at, kind of in this bridging that I was discussing, we've gone from really an infancy of assurance where things were very loose and free, both in Windows and the rest of Microsoft, to having at least a stake in the ground with the efforts that Steve Lipner's team with SWI have produced with security development lifecycle. And so we see ourselves as then extending beyond that to add even additional higher assurance for this hypervisor we've been talking about, which is going to be the foundation for future operating systems running on top of it. So this slide just reiterates kind of those same points I was just making. Trying to put together the right elements, knowing that any one specific element isn't going to give you high assurance. You know, if you're doing threat modeling, that's not enough to just give you high assurance. If you're doing formal methods, that's not enough on its own to give you high assurance. By taking a bunch of elements that we're going to drill down into and layering them together, we feel like we've developed a process that gives us that level of assurance that we're trying to meet the goals we set forward. And then determining, you know, all those pieces of the process may not apply equally to all aspects of the product. So the elements of the product that have most access to critical resources, hardware resources, privilege level, access to the TPM, et cetera. So obviously looking kind of at the lowest level, the hypervisor, and moving up, applying the most rigor to the more key low-level components, and then potentially a lesser amount of rigor to components that are outside of that. And kind of a final point is this is a process that we've been developing for the last year or so. It's really an ongoing process, so this is the first chance we've had to talk to all of you as a group, although individually we've talked to several of you to get feedback. We do want to hear what feedback you have, and we do want to make this process fit the goals that we're trying to meet. So if you have good suggestions, that kind of brings me to the questions that I want all of you to keep in mind. You know, given the goals that we just described, do the processes we're going to talk about seem to fit those goals? Are they not enough, too much? Are there things that you would change about the tactics we're taking to put high assurance into Windows and into Microsoft? And is there a particular area of expertise that you could actually lend some help to us on some areas where we're still making decisions on what the right thing to do is? We talked a little about covert channels. We can talk about that maybe when we get to the threat modeling slide. Formal methods is another area that I'd like to get some feedback on. But as we go through all of these elements, kind of keep these in mind. If we get to a specific area and you want to ask some questions while we're at that area, that's great. Otherwise, we can take questions at the end as well. So this slide is going to be really hard to read, but having done a review, I believe, with the SWI team on the security development lifecycle, what we're trying to show here is that that's added quite a few elements along this timeline, moving kind of from left to right of requirement stage, design stage, implementation, verification, release, and then response post-release efforts. And so on the top of the dotted line is all the efforts that the SDL process is already putting in place as a baseline for Windows. Then for each of those segments, we've tried to add additional higher assurance elements in, and all these will go into more detail, so don't worry too much if you can't see the specifics on this slide very well. Yeah.
Only some products will go through below the line.
Right.
All will go above the line.
Yeah. So the process above the line is something that's been pushed out into Windows. So all of Windows for sure will go through that. I know. Yeah, and Steve has been trying to. Yeah. So it's all of Microsoft now. It sounds like is our stance on that. So this is a big step forward for us. You know, this work started with the security stand down we did for Windows, and it's something that's really been grown by Steve's team, and there's been a lot of detail that's gotten pushed into a lot of products that have already come out the door, but now going forward for all the products at Microsoft. And so HASE is something we developed specifically for NGSCB originally and Unity now. But we're trying to develop a model that could be pioneering, spearheading higher assurance that other critical components within the organizations could go through as well. So we'd like to think that at the end of the road, we'll have some good learning from all these after applying them to Unity, and we'll be able to work at maybe driving additional things into the SDL just as a common baseline. So this tries to show a little more clearly, hopefully, the breakout of the elements that we're adding. So some of these are things that overlap with the efforts that are going on in the SDL, but many of these are things that go beyond that, and certainly go beyond traditional Microsoft practice as of a couple years ago. So at the design and infrastructure stage, ensuring that we have good solid security requirements up front. We're building design documentation up front, looking at layering, modularization, complexity minimization, as well as just code size minimization. Looking at threat and privacy models, having a secure build environment for the code to get developed within, looking at how we can use formal specifications within the system, implementation, having good, solid coding guidelines and code review practices, having correspondence between the code and the specification, doing verification just with traditional testing methods as well as adding more red team penetration testing methods, having really a set of quality gates, a gauntlet as we often call it, to separate out the code between two trees, a main line and a staging tree, and we'll go into more detail on all of these later. And building some high assurance tools to help us with the verification effort as well. And then once you release, it's clearly not over. We have to be paying attention and have good plans in place for update.
The word proof doesn't appear on that slide.
It does.
Is that buried in correspondence evaluation slide, or is it deliberately left off?
So it's kind of under formal specification and verification. It's not explicitly on this slide. I have a couple slides on formal methods where I would definitely like to talk a little more about proof.
Let me ask the question differently.
Yeah.
I'm reading that slide as the stuff you're really going to do. And the first slide had, quote, verifiable code under that. It knocked me out of my seat when I saw it. So the first slide was more of a hype goal.
Yes.
This is more reality.
So we do intend to do some proof work to get to the punchline now. But the amount of work we're going to do is still something we're scoping. So why don't we hold that until we get to that slide, but I do want to talk certainly in more detail on what our plans are around that and what things we think we would potentially prove.
Another flip of that is that there are some elements on that slide that I assume the SDL already.
That's right. Yeah, this.
It really becomes a diff. For instance, in design and infrastructure, I think it's just total specification.
Yeah. So I'll try and talk to that as we go through the elements. Some of these do overlap a bit with, and in some cases a lot, with the efforts in the SDL already. For most of these items, though, there's some additional bit we're doing that's beyond the efforts that are being required by the SDL currently. And I'll try and talk to that on each of the slides. But this was to try and give a coverage of the whole scope of the HASE process, some of which is indeed well in sync with SDL.
All right, I'm going to start talking about the first element, which was notion of us having some defined security requirements to help us in the process of designing this system. We often use this presentation to sort of talk about the things that we're doing both inside and outside of Microsoft to non-security experts, so I don't really need to discuss the rationale or the reasoning behind these things. I think you all pretty well understand that. What I think is important to show here is that we're actually sort of trying to take that internally and think about weighing a lot of our decisions for design based off of something concrete that we can work off of, and this is where these security requirements come into play. We talked about earlier before, how do we make those trade-offs between deciding between performance and security features. The way we can really kind of capture that and sort of help define what those trade-offs are actually measuring those back to a set of security requirements that we've defined. This also sort of helps guide the HASE focus. We'll talk about this a little bit more later on setting priorities on which portions of the project we're able to apply this process to entirely. We have limited resources. A lot of these processes are fairly expensive if taken to extreme, and we need to have some way to judge which portions of the system require the most rigor for our HASE process to be applied to. Also,
An example of a security requirement?
yeah, we'll get to that in the next slide. So let's go ahead and flip to that. I know we're fairly limited on time. It's a fairly dense slide here. Overall, sort of our top level security requirement is that ensure the protection of user data and data processing systems through the creation and management of isolated partitions. For the top level goal for the project. Now within that, we have defined specific security requirements. For instance, that the confidentiality and integrity of data within partitions must be maintained. Information flows between partitions are controlled by Unity, protected against tampering, spoofing, and disclosure. Confidentiality of data persisted to disk must be protected against unauthorized principals. Also, the unauthorized modifications, this is the integrity portion of persisted data, must be detectable. Right? Access to physical memory is controlled by Unity, specifically the hypervisor, even through code running in ring 0 within all partitions and hardware DMA devices. Also, going back to some of the user interface, user experience types of requirements, some samples of these include a user must be able to determine which partition will receive keyboard and mouse input. Users must be able to determine which partition controls the screen or region of the screen. We also have additional ones. For instance, that code running within one partition should not be able to derive the position, size, and state of windows and other trusted partitions. Now, going to the assurance side of the requirements, we have a sort of overall guiding goal for assurance requirements that we wish to reduce the unintended flaws in the specification, design, implementation, and delivery of the system. And a lot of this overall HASE process goes to ensuring those assurance requirements. We're also concerned about reducing intentional flaws that might be introduced by the system through parties external to Microsoft. I mean, this is really kind of getting to the insider threat issue. Our major concern is that the code that we build sort of, in a sense, follows a chain of custody so that we can have assurance that what we've specified is what we've built, and that what we've built is what we end up shipping. And as part of that, we sort of have shared responsibility or accountability for all actions throughout the process. And this is starting to sound a little bit more like sort of the government side of assurance and security requirements. It's not that we're really necessarily concerned that people are going to directly try to tamper with our code base, but all of these things come back to assurance. We need to be able to provide assurance to others that even if somebody had wanted to, they wouldn't have been able to.
So from a documentation perspective, a lot of this is... Oh, go ahead, Father.
I just want to understand some of the stuff that's being described.
Okay.
If the data on the disk is going to be protected, who writes that data? The NT file system, right?
That's correct.
So you're going to extend this to the entire NT system. This isn't just going to be for the hypervisor.
So this is from the standpoint of any partition should be able to, if it wishes to, persist data to disk such that confidentiality is maintained. This is provided through, as Paul mentioned earlier, this notion of a secure virtual hard drive. Right? Encryption provided through the Unity system, right, as a service to partitions to make use of if they wish in writing data, which is ultimately encrypted and sealed to a secret that's ultimately sealed to the TPM.
This is just going to keep the partitions out of each other's hair. It's not going to be the principles out of each other's hair.
Principle from this notion of user or subject is, subject beyond partition is not something that we're really dealing with here yet, at least the standpoint.
So from a design documentation perspective, a lot of this is going to be something similar to the SDL process, ensuring that we have good design documentation. Extra pieces we're adding here are ensuring that the documentation is built in a way that we can provide correspondence between the various levels of documentation, so kind of following a common criteria style, having a top-level functional spec with the architecture of the system, high-level designs for the subsystems, low-level designs for the individual components, and being able to show some level of correspondence in the documentation, as well as having a good audit trail for all of the documentation through configuration management. And so all the code and documents, and we'll talk a little bit about this in the slide on the gauntlet process, is something that goes through a review process. So we do have this staging domain line where we vet any code or any document, and before it moves into the actual production environment, it can be checked in and checkpointed, but it doesn't actually move until it's been gated by an official review. So this slide goes into details we've covered quite a bit, I think, in the previous two talks, so I won't dwell too much on this. But we have been trying to push from a HASE perspective a goal of providing layering into the system, refactoring the system, and minimizing both the dependencies and complexity, as well as minimizing the code size, to ensure that we've got the smallest system we can provide the functionality with, and to provide, breaking of any dependencies that are violating the layering principles.
When you say TCAAB here now, are you including the hypervisor plus
The hyper...
TSP win?
Right.
Well, there's sort of, in a sense,
1 million lines of code.
there are multiple layers within the TCB. So we define sort of at the most fundamental level the hypervisor and the hypervisor's configuration data, and anything that's able to modify the hypervisor's configuration data is sort of the base level. The next level on top of that would be an extension to any other code which is providing for other security functionality that we're stating that we provide for the system. Trusted input, trusted output, for instance. Sealed storage and crypto services. And that actually starts to be where you start to expand that scope to include things like TSP-WIN and its million lines of code.
And so that's one of the challenges we actually have, and we talked a little bit about the componentization effort already, but in trying to move from our model where we controlled all of the code in NGSCB, and it could be tens of thousands of lines, to a model where we're leveraging Windows for all of these partitions, that's why the componentization and pushing to even further the efforts that Windows is already doing to get to a TSP-WIN that's stripped down to some percentage of the initial Windows code base. So if it's initially 100 million lines of code, stripping it down to 1 million is 1% of the original code base. That's still a significant amount of code, though, in comparison to what our original security model was, and that's something that is a challenge for us. So providing trusted services in that partition is, if there's any additional feedback you can give us on doing that well, we would certainly take it.
You're saying that you're going to do the bullet on the slide, that million lines of code? Or not?
We're saying that our goal is to apply all of these. They'll be applied at different levels. So we've done from 100 million lines of code to 1 million lines of code some minimization. But most of these are mainly meant for the hypervisor level of the TCB, which is kind of the root foundation at which everything else sits on top of.
How big is that part?
Paul, can you give a current line of code count roughly for everyone?
I would estimate less than 100,000.
Less than 100,000 was the, yeah.
And what language is that already in?
It's in C and assembly. So threat modeling is a key to ensuring the assurance of the system, knowing what the assets are, what threats you're trying to protect against. Again, this is something that we've driven into all of the products at some level through the SDL. This is kind of where we get to looking at, from a high assurance perspective, what additional things can we do there, what penetration testing can we do, and we'll talk a little more about that later, to ensure that all of the threats and mitigations that we believe are in place for those threats are working properly, as well as looking at things like the covert channel analysis and saying, how would we do analysis of covert channels as well as the overt channel?
It seems to me that threat modeling, Paul and I have had this talk offline. It seems to me that there are two major outcomes influence of the design. I think that
Definitely.
understand, you're building this specifically to provide a more secure user experience. And so I think threat modeling will help drive the design decisions that you make better than any other process that you put in security. The second major outcome of threat modeling, you're kind of developing something that hasn't been done before, at least in this company.
Right.
And I think you're going to be woefully short on good tools for doing that. I think a lot of the low-level tools that Windows teams use, some of them will be useful,
Yep.
and some of them won't be useful. And so I think it's going to expose your tool needs quickly as well. And then I think that's a real serious staffing issue. I don't see how your test team can survive without dedicated assets, writing tools soon so that they're ready for prime time when developers have something to test.
Right. I think those are all very good points. In terms of doing things early, we have kind of a detailed process for the various specifications we talked about, the high-level designs and low-level designs, which kind of specifies getting the threat modeling done early and embedding it in those specifications so that when people review the specification, they're also reviewing the threat model. From a tools perspective, there is only a limited set of tools out there right now, so as more tools come available, that'll be important. We do have yeah, and we do have some dedicated heads working on building tools. We'll talk a little bit about tools later, but certainly Brandon's penetration test team, which is dedicated to the HASE effort, will be involved in building some additional tools there, and we also have some development resources, SDEs as well, that'll be involved in that. Certainly there's, well, I think there's certainly pieces of that we can leverage.
Yeah, there's several things which, for instance, since it's not a true sort of purest sense of a hypervisor, and we do have reliance on a primary partition, that introduces another set of threats which didn't necessarily exist in previous hypervisors before. There's also the notion of So precisely right. So if you think about the notion of the threat modeling is to think about ways in which an adversary might try to attack the system or where potential vulnerabilities might exist. Even though we say that we have mitigations in place such that the primary should not be able to compromise confidentiality or integrity, that absolutely must be part of our threat model, and we have to test against that to ensure that under no conditions can an adversary try to circumvent the primary partition and compromise one of our security requirements.
We'd certainly be happy to talk to you about existing threat models and sit down more on that. So formal specification and analysis. Trying to put in place some additional rigor so that as we're designing this product, we're paying closer attention to modeling the code, having an understanding of how it's going to work, having a clear specification that removes ambiguity with the informal specifications we almost invariably always use here at Microsoft and widely in the industry as well. And using formal specifications to find additional bugs that we might not have been able to find without the formal specifications. So in terms of how we've been applying this, historically, when we were working on the NGSCB product, there were two levels of efforts that we undertook. We tried to leverage existing Microsoft research technologies for specifications. There's the abstract state machine modeling language, as well as the TLA language from Leslie Lamport. We started by modeling the page table entry edit control, also called the address translation control. And that's one of the key pieces that gates in the old NSCOB architecture, the isolation between applications. And so that was modeled in ASML and then modeled in first-order logic that produced C code directly from the model and was proved by Ernie Cohen, who I don't know if some of you may be familiar with. And then the security reference monitor in the old NGSCB architecture, we were building our own because we were building our own OS. So we had done a model for that using TLA and started down the road of both providing that modeling for development and for testing. So in order to ramp this up into the team, we've definitely run into some hurdles with getting acceptance of formal methodology. There's difficulties just with skill set, with the team understanding the logic and understanding the notation of using some of these formal methods languages, as well as changing the process that developers and architects use to design the code. And so we've had training. We brought Leslie Lampert up, and he actually delivered a day of TLA training. That still left us with some parties who were very accepting of that and others who weren't. So we've decided to change our tactic a bit. We've decided to actually bring in, so one of the issues that we also saw was just expertise. Even if I understood the language, could I properly model it using the language if I didn't have that experience, years of experience writing a formal model? And then to do the proof even being an additional burden on top of that most people were completely unfamiliar with. So our new plan is to contract with one of the formal methods shops that's been out there doing this in industry, doing this for security systems, and to bring them in-house so they can work with the architecture and development team on some of these critical components, particularly looking at kind of the hypervisor external interfaces as the first item we'll probably look at, then trying to scope out what additional critical items, so not using this ATC control anymore. We still have some memory isolation using shadow page tables, so we may investigate applying formal methods to that as well, potentially to other critical components, extensions we may be doing to the SRM. So we definitely would like to hear, I know there's a wide variety of opinions on whether we should be applying this, what level we should be applying it, so guidance would be great from you guys. Fred? Both.
So what shop are you talking about?
Praxis, Critical Systems.
So my concern is that, well, I don't take this as an argument to use formal method. That's a different discussion.
Sure.
But I'm concerned that the people who are writing the specifications aren't going to be able to do a good job of it unless they have to do it. Because, well, it's, kind of making your own bed in line.
Right.
And so this kind of partitioning just seems like it's going to involve, you're spending a lot of money on Praxis and you're wasting a lot of your people's time.
So our plan would be for them to be writing the specifications, the formal version of the informal specifications, hand in hand. They'll be sitting here in Redmond working with us. I also have a concern of integrating them in well. It's kind of a tactic that we felt was a better one where we actually had, if we were going to get some of this additional rigor into the system, that we had enough people with this expertise to do it. And that seemed to be one of the blocking points for us in the past. So bringing folks in who could sit with us and then also be doing some training so that the people who did have the aptitude and interest in taking this forward, so Marcus, who looks like it's in the back still, has some experience doing this. He's the one who worked on the original ASML model. We do have a handful of people in-house who could continue to carry on some of this work, but I think having the expertise in-house was what we really thought was the benefit we were getting here, and having the people with the experience working on more formal models for security systems as well with the Praxis.
Require Praxis to use one of the in-house TLA or ASML, or are you going to let them use the equivalent?
So that's something still under debate. Our work with Praxis is really in its infancy. We've been just in the contract negotiation. They'll probably be coming out here in the next month. So we've discussed with them kind of benefits we get by using the in-house stuff, obviously having resources here in-house that are experts on both of those. But neither of them are areas that Praxis has used before. They were familiar with TLA. They weren't familiar at all with ASML. So we've discussed those issues with them. They have experience using a range of things. They generally have their own Spark Ada stuff that they've been using, but they've also built stuff using Zed and some of the other modeling languages. So they were open to working with us if that was a driving factor for us. So I think we'll be able to come to a workable compromise with them. Jeanette?
If you have a short-term goal to apply formal methods to the hypervisor, for instance, don't have the expertise locally right now, I can see why it makes sense for you to go to Praxis. But in the long term, hope that Microsoft will adopt HASE or some, maybe, some more rigorous methods, maybe not as rigorous as you're outlining. You're going to have to either train your own or start hiring people with a skill set. So this is a short-term solution for something that
Yeah,
you recognize.
yeah, I definitely agree with you.
And
It's
there's, I suppose it would be a non-trivial amount of money to actually hire Praxis to do this. But someone made the decision that
yeah. So we had put money in our budget to do HASE work. So certainly this is something we thought would give us some benefit. We're looking to do kind of an exploratory work with them at first, see how that work goes, and then if it's going well for us all around, to continue that work. As for growing the team, I definitely take that point. I think having people in-house who can do the work is going to be critical to our success in the long run. What we're trying to get to for V1 is certainly the state where people could all understand and read the formal methods. So from a testing perspective, which is where my heart is, being able to see some of these more detailed formal specifications. I've run into problems constantly as a test manager and as an individual tester prior to that with specifications that are just so poorly written and ambiguous that either you constantly have to be making choices or you have to constantly be clarifying the specifications. And at any point where a tester is making a decision on something that's ambiguous, there's a chance that they're going to make a decision different than the decision the developer made when they read the same specification. And there's certainly a process to clarify that in the specification, but I think doing that up front and having a specification that we can test against at a clear level, and particularly having a model that we can test against as well, is something that we felt was going to be a benefit for us. But it's something that's an exploratory thing for Microsoft that we obviously haven't had a lot of experience with in the past. And
Outsourcing this stuff is just crazy. Most of the benefit is by having it for the life cycle of the system, by being able to make changes and then use it to help you decide what to do. If you outsource it, then you're basically doing it for a snapshot. And if you ever change the system, the proof will not be sound anymore. You will lose your certification, and your entire investment in the formal method gets thrown out. They're not going to sign, they're not going to buy Praxis, and they're not going to keep Praxis around for the life cycle of the system. So what are you going to do instead?
Get some training.
I think people,
But this would be hands-on training. I like this better than. Steve, why don't you just
I outsourced my formal method. Huh?
You hired people, I came in and taught the classes.
I had some in-house capability, but the final analysis, I outsourced the TIS.
Can I ask a question based on this? I'm the group program manager for NGSCB Unity up here with you guys. Are you advocating when you say that we should not outsource formal methods, that it's better not to do formal methods?
No.
no, not at all.
Okay. Well, that's kind of where we're at on this project. So formal methods, we don't, like Tim and Brandon stated, we don't have the expertise in-house. We are planning to hire people to come and train us and ask questions and solicit input from bodies such as yourself and so forth. But given the time to get a product out and get that training
I
done.
actually understand this part about giving the time to get a product out. I understand about the longhorn pressure, but what's the pressure of getting hypervisor out? I mean, what's
Welcome to somewhere.
I mean, here's actually here's a different concern. What I heard this morning was Microsoft seems to be making this choice between doing NSCUB properly, which is what hypervisor is all about in the long-term vision of hypervisor, and Longhorn. And what I was hearing was that Longhorn was dictating the design decisions and compromising the good design decisions of the NSCUB proper NSCUB with hypervisor and so on.
So I don't think that's wrong.
And then when you go out and hire practices and say, we're going to use this HASE technology process with formal methods, and if NSCUB or hypervisor fails, this is going to fall down with it. That's the concern.
Fails in terms of security threats.
Never comes to be. Never comes to be because Longhorn has got so much inertia, and Microsoft has such a large customer base, and you've got to be out compatible because that's principle number one of Microsoft. And that all of this is beautiful design and really smart people doing creative thinking, all for naught.
This has nothing to do with that.
Well, I heard there was a balance this morning between like Longhorn was.
So there is a bit of a balance in doing server consolidation, which you could call app compat. And the hypervisor is trying to serve both of those roles, the server consolidation role that kind of is a takeoff from the VPC efforts for virtualization, as well as the security role, which is a takeoff from the NGSCB effort. So it is a pairing of both of those.
That's the real hazard of this project. Is putting these two goals together is going to result in a system that meets neither.
I hope that's not the case, but
that is the real hazard, not
yes.
the thing we've been talking about.
It seems to me that there's two different things that get in the mix. One is you like to check a box when you ship version 1 saying we did formal methods. And it's possible that your current plan is okay for that. But for the long term, this doesn't seem quite as good as it could be for all the reasons that were already brought up.
Yeah. And to be clear, I don't just want to check a box. This isn't for common criteria that I want to do this. This is for increasing the assurance level that we have in what we ship.
Well, I'm not sure this will achieve that. And I don't think that the choice is between not doing formal methods and doing it by outsourcing it. And certainly, from what you've presented so far has been very vague. You've not said where you're going to do what. Some things appear on early slides and they disappear on later slides. And from that, I don't really know how much of this is a sales talk for vision and how much of it is a real plan. And so I don't have enough information to decide that that is the only choice that needs to be made.
Okay,
You have
fair enough.
two good groups in research that do verification specification, one of which, the TLA stuff, is like world-class stuff. And it's
Agreed.
just incredible to me that you wouldn't try to use that stuff, even if it means growing a bunch of people in development that can do it.
So, and that was certainly our effort. Make no mistake, that was our hope that we would get to that stage. But seeing the degree of difficulty and setbacks we had in trying to get developers to change their mindset and be able to write specifications,
But the result of that is
I wish you had been in that meeting, because maybe you would have.
That the whole thing's going to be cosmetic. That's an unavoidable consequence. And maybe you can't do any better, but you should be aware that that's what's going to happen.
Which group of developers are we talking about here?
The Unity developers.
Hypervisor developers.
Yeah.
How many people are we talking about?
In development, that's roughly 30. No, for hypervisor and NGSCB.
Oh, and then, yeah.
The whole Unity project together
The
is.
hypervisor itself is probably 10, and like another 20 is Tim just
So
said for the whole
is the
project.
problem all 30 or just the 10?
Technically all 30.
So
But formal methods
30
is
is not
clear
like,
is only on parts of the hypervisor, these guys.
it seems like 30 is not possible to get further education, right? When it's Longhorn development team, it seems impossible.
Yeah, and it doesn't seem impossible to me either, and that's certainly our hope, is that in the long term, while we're going through this life cycle of building out RV1, people are getting trained up. And hopefully at the end of that, we do have, maybe it's not 30, maybe it is 5 or 10 people in-house who are quite capable at it.
What about Jeanette's question about the time pressure?
Yep.
If you took a whatever month hit and said, look, we're just going to we're going to try this. Whether you like it or not, we're going to try this, and we're going to slow things down. How bad is that? Does that mean you guys miss your window or something?
Well, certainly there's business pressure to ship as soon as possible in the Longhorn time frame, right? That's pressure we get from above.
Longhorn, right?
What's that?
You can't be later than Longhorn. Is that
I don't know that I would say that, but certainly we need to be in that time frame.
You don't need to be before Longhorn.
No.
Right, that's true.
We rely on Longhorn.
Right.
Then you don't have that same time pressure.
I mean, it sounds like
Well, we do have some time pressure,
Yeah.
certainly to release, a product that can make Windows better in the Longhorn time frame. And so I don't think training people is going to be a week or 2 weeks or a month process from what I saw. And I actually wish a couple of you could have been there when we did the training, because maybe you could have provided more ideas on, the ramp-up cycle people normally take that you see.
You spent 1 day, right? You got Leslie Lamport to give a day's worth of lectures.
Well, that's true. To be clear, there was a smaller group that we actually worked with him for quite some time as well. But we spent about a month of some people's time ramping up on that before he came out to give a broader to the 30, 60 people.
Yeah, but this is an education. I mean,
Yeah.
I just want to point out right now before I say this, is I have never taught this material. However, there's people around this room who do this for a living.
Yep.
And it seems to me this is an education problem of which educators ought to step up if they believe strongly in this opportunity and help solve the problem.
I would appreciate that.
See that one coming.
So why don't we move on? This is something where I'd like to certainly keep the dialogue going after this presentation potentially as well. James?
Wildly unpopular and everyone's going to hate it. Have you looked at any lightweight formal method techniques? For example, clean room?
What was your example?
Clean room.
Clean room I'm not familiar with. So we have looked at things like, could you use, is there kind of a middle ground? We've talked a little bit about with UML to do some level of...
Yes,
Yep.
so UML is using very, very lightweight.
Right, exactly.
Structured specifications, right?
Yep.
And documented ways of specifying input-output pairs and state combinations. Now, these things have been around since the early 1980s, probably earlier than that when I did that. And, they work. They force people to write specs that are complete and understandable. So you can't do a formal proof, but you can do a lot of very strong informal proofs. There's books on the subject.
Yeah. And so we certainly have looked at the difference of just doing some modeling as opposed to doing full proof work to say, maybe we're not going to prove these things, but being able to model them and see if
Have you
assumptions
started that idea?
can hold through. Well, the ASML effort really goes more in that line than the TLA effort. So some of our initial work in ASML, we've kind of moved a little away from that actually, but it's certainly possible we'll revisit that. So I know you've been waiting for a while, so I'll let you ask your question, but then I think we really need to move on to the next one.
This may be completely crazy, but you're trying to do something here that is a little bit non-standard, right, compared to the normal Microsoft development practice. You're trying to do
Very
something
non-standard.
that has a higher quality of assurance. So maybe you can't do it with a normal standard issue Microsoft development team. Maybe you actually need to put some filters on how you build a team. And maybe decide that how many people you need who can write the TLI specs, and make sure the team includes those people. Either to train them and make them pass the course to get the slot, or find people who have some experience. I mean, is that kind of just completely?
I think it's a good idea, but from...
That's probably maybe the only way that I see from
I really can't believe we can't find more people in the company who can do it.
But remember one of the things out of my slides, and one of my slides at the very beginning, is it get fairly strong guidance from management not to do things totally differently from the way Microsoft usually does things?
So it can have bugs. The way Microsoft usually does things, it has bugs. So don't apply it.
This is pretty radical, not just to do formal methods, but to outsource it. How does that?
There's nothing radical about that. That's cosmetic. It's completely the opposite of radical. Radical would be actually teaching the developers to do it.
Well, how does management?
And that's not practical because it slows things down too much. I mean, what's surprising about this?
So how is management agreeing with this?
The thing that is driving this whole project is the desire to have a great story to tell about server consolidation. Not the thing that's driving this project is not high assurance.
Well, I would disagree with that characterization,
Of course,
but I think
I'm sure you would, but I believe it is actually true.
It is a driver.
That's what people think they're going to sell.
So the question is, how much are we willing to pay for cosmetics?
Well, actually,
It's going to be an extremely expensive exercise.
this is hitting on the crux of our problem, and that is the company wants to see an ROI on efforts such as this. That's return on investment for those of you. Okay. So
thank you very much.
yeah. So we are now at the point that, I think last time we presented to you, we talked about shooting for high assurance level like EAL6 and so forth. That has all been basically stepped down based on the fact that we cannot get the budget to do the cost of doing this the way I think you are all advocating. So one thing that can help us is if you strongly believe in this kind of thing happening at Microsoft as a group, telling that to our executive management staff would surely help. What we've done as a team here is try to do the best that we can given the support we're given in terms of budget and resources in terms of headcount and so forth to do this kind of thing. And
Who is your executive management?
our executive management,
Who needs to hear this?
this needs to be heard by people like Jim Alchin, Brian Valentine.
What these guys are saying is there's no money in this high assurance stuff.
Yeah,
they're right.
Well,
There is no money.
I don't know if they're saying that, but they're definitely saying, can you show us that there's going to be money? Can you show us a plan that
I don't think anyone in this room can convince you that there's money in high assurance.
Can I just change this?
All the available evidence says there isn't. We came from
I thought
But wait,
I thought you were doing, I kind of naively thought you were doing an experiment. You were the experiment. Let's try high assurance and see how much it costs and what the benefit was. Or did you kind of need proof in advance of that?
I don't know if I characterize it as an experiment such as you would do in like Microsoft Research or something. This is a product group. So we have a product deliverable, and we're expected to generate money from that product at some point.
And which product is yours? Is it the high assurance version of the hypervisor, or is it the hypervisor?
Well, I don't know if I characterize it like that. I'm the group program manager for Unity, which is the entirety of the software that runs on top of the hypervisor coming out of the Windows Security group.
So my understanding was that what you called Unity was supposed to basically supplant Windows in the 10-year time frame and make everybody believe that Microsoft produces trustworthy software.
So we are in Windows. So the hypervisor is part of Windows, and it is the long-term roadmap for the hypervisor to run underneath all copies of Windows and to get to this device assignment and more availability for sure.
So the way I think of it then, independent of the checkbox problem, I understand that. You have we need to use all the techniques available to us to make sure that in 10 years, your stuff doesn't crash and it's as reliable as the damn telephone is.
That's right.
Precisely right.
Somebody had the vision that there's this whole body of work about assurance that ought to be brought to bear, because otherwise you can do only so much with programmers and architecture, and then you reach a point where you actually have to evaluate the code using some technique, and pioneered automatic ways to evaluate device drivers and so on, with SLAM and Postfix and so on. And now you've got to bring to bear the right techniques, the hypervisor. So that says there's no way to do an ROI investment on this short term it says, this is the basis for you to buy the vision that Scott sold us Tuesday afternoon when he explained why Microsoft went into the trustworthy computing business. And then you either have to do it right or cut back and don't do in a half-assed stuff that isn't going to pay off. And I
think you find we agree with those statements. But we're kind of trying to manage.
The management doesn't.
Yeah, and we're trying to manage with what we have. We're trying to do the best in spirit of that with what we have.
Well, I would like, the point was to complain about what these guys are doing. They're only complaining you can bring to these guys that they have not gone to their management and said, the task you've given us is impossible.
So why don't we move on? We've got quite a few slides to keep rolling through.
Well, actually,
Those are the facts.
2 minutes.
yeah, okay. We need to, Greg.
Okay.
But just one, this is stuff in the closed session we can come back to if the group feels strongly it seems to. You know, this is something that can go into group recommendations for like.
They've got a couple more slides they got to get to, and then it turns into closed board session, so let's chop.
Okay, so we've got quite a few slides, but I'll just say a little about them.
Okay.
One quick question. I count tools, code review tools like prefix, that's formal methods. What we plan to use there?
So, yeah, so I'm not sure that I would call code review as formal methods per se, but it certainly is.
I count tools that find bugs.
Okay, and that's certainly, I take that comment. So we have tools. Yep.
Other than the ones that already exist for.
Yeah, so we are working on developing additional tools, which why don't I just go through. So code reviews, we're working on tools that in the future will at least allow us to uphold the coding standards and coding guidelines, which I haven't had time to go into, but which we have a full document on. We're looking at tools that can potentially expand upon. Windows has started to do as part of this Longhorn code merge effort, which I'm not sure if you guys have heard much about yet, has started to use some level of annotations. So we're looking at how we can use annotations, code annotations, things like the C-cured effort from Berkeley. There's efforts here within research in the PPRC, Program Productivity Tools team, to extend prefix and prefast to allow us to do some annotation work there. And so we're certainly looking in that direction. We're seeing if we can build some tools. Let me see if I can get to tools. Some tools that do dependency and layering analysis. So that's a tool we have underway right now within the team to be able to analyze the graph, the dependencies between be it DLLs or the code and functions within the DLLs, as well as then to build a constraint system that as we're building the product, we can constantly be checking to see that we're not violating the constraints of the layering model. And so that's certainly some of the tools that we're building. And we would love to build a suite of tools that we could both use as well as leverage within Windows elsewhere. Yes.
One thing I was thinking about is those slides when you talk about security against vulnerabilities, security properties, and such as what's the kinds of human security issues that raises for Microsoft? I guess one possible solution is you just make sure there are lots and lots of eyeballs, preferably unpredictable eyeballs. How can you go into a little bit more detail?
Yeah. So. Let me cover this slide and see if it covers some of your questions. So we've built a secure build environment that isolates a separate domain off of the main Microsoft CorpNet to ensure that any viruses, exposure, hacking attempts on CorpNet itself aren't taking themselves all the way over to the secure build environment. This has both physical security, so we have a ComSec approved safe that's a kind of government standard safe for intelligence military work that the servers live in. We then have a cage environment around that, building environment. So there's physical access from personnel that's well secured, and we can audit the trail of card key access and key access to log into these machines all the way through most of those pieces, as well as then having our own domain and domain accounts issued only to members of the team so that the only people who can access our source code in the depot are members of the team, and so we can audit that as well. We're looking at using the smart cards that all the employees have as another gating factor, a two-factor authentication. And so that's some level of the efforts we're going to ensure the access from tampering of threats. And then auditing, as I say, is kind of a key to all of those pieces.
So, going to the audience, one question is what about security from the members?
So the members of the team themselves, in terms of personnel security, that's something that, we initially talked when we were looking to do high assurance certification, EAL6, et cetera, back in the NGSCB days, potentially getting clearance levels for members of the team. We haven't gone that far since we backed off of that effort. So our main security from a personnel perspective is just the members of the team are all full-time employees. We don't have any contractors accessing the source code, making changes to the source code. All the work is done local. We don't have any remote users. And by having our own separate domain, remote users at some of our isolated sites in the India Development Center or what have you, where we have less control, don't have access to our domain, which isn't on the CorpNet directly.
Now, Tim had to. Yeah. Could you flip back to the code review slide?
Oh, on code? Okay.
Yeah. So we had to flip past one of them really fast. We actually have a mandated code review process. Yeah.
So for individual pieces of code, the informal code review is just a single, it's kind of a fairly standard Microsoft effort, which is just a single buddy, reviewing your code, so a developer would have another developer review the code. The more formal review is a process that we're still defining. We haven't kind of settled exactly on what that will be, but certainly it will be at least another developer, probably the developer lead for that component, as well as the SDET, the developer and test for that same component. And if it's an architectural change, one of the architects as well.
And the external?
And the external is, going through, that'll probably be a part of some of the audits that we do for major releases. So for the beta or for the release, the actual RTM, where we bring folks in and allow them to do some amount of editing. In addition, government folks that we're working with in the US and UK, in particular, will be doing some amount of review. Certainly, internally we will. Externally, the amount of the code that gets reviewed externally, I think, is still an unknown to us because we haven't done any of that work yet.
Certainly the case that with, for instance, the hypervisor, we would hope that it's reasonable enough in size that somebody spending a fair bit of time, not so much, but a few people, a few weeks, a few months would be able to actually go through and read through all the code for it. And we actually we've stated before, especially back in the Palladium days, that we intended to make the source code widely available for review. And I believe that plan still holds around the hypervisor to make that available to security experts to review that, to both get their opinion and feedback on that, but then also to have them be able to make some statement about what they feel the quality of the software is.
Yep. So correspondence we talked about already. I'm not going to spend much time on that.
I think there's one thing we actually weren't able to go into so much detail yet, too. On this code review and this gauntlet process, should we point out that really the way it works out is that all developers have the ability to check into a staging environment. Now, in order for the code to actually move to our production, our actual real build environment, it has to go through these quality gates. And that is the mandatory code review process, and a lot of the code analysis tools are applied at that point. Only if it meets and clears the code review tools, and only if it has gotten sign-off for the code review and the spec review process, can code move from staging to production. There is no mechanism by which any developer can directly check into the production tree or modify stuff in the production tree.
And that's something that you see a little bit of that now happening with the Longhorn code merge as well, but I think we're still at a level where we're doing a higher level of that with all of the code and for all the check-ins. So HASE tools we discussed pretty much at the wrap-up here almost. So once we release, we still have to be sure we have a plan for doing patching if bugs are found, having a response plan, so integrating our updates with the traditional Windows update process and working with MSRC to handle responses. There's nothing really inherently new there except for the issue of the fact we have this data that's been encrypted and sealed for each of these SVH, the secure virtual hard drives that the partitions are running. And so because we have these secrets bound to the TPM, there is some extra due diligence we're having to do for an update process to be sure it's really a legitimate update that's trying to migrate your secrets potentially to a new OS. And so there's some work we're doing for that. I think we've kind of covered this slide already. We're going to be looking at all these elements, but then prioritizing how we apply them to the individual components based on what critical access they use, what privilege level they run at, are they accessing hardware directly, do they need to do that, and then breaking out the systems into buckets based on that. We touched a little on certification. I think the last time you guys were here to hear about NGSCB, we talked about EAL6. I wasn't there, so I don't remember exactly what the deck looked like, but our current plan is to submit just as part of the standard Windows Longhorn common criteria process, which will be under the SLOS protection profile. But looking at, are there additional profiles that we can both take advantage of any security requirements and items that look like they're well suited to us. There's a brand new protection profile that's out called the separation kernel for high robustness environments, which looks a lot like the hypervisor and is something that, except for the availability with the scheduler issues, we could probably meet most of the issues, most of the requirements there. So that's something we're looking at to see if that's somewhere we can go in the future, if there's an effort. Should we be shooting to certify at a higher EAL level than Windows? That's certainly something that's open for debate, and that we'd still be willing to hear feedback on that as well. So, just as our wrap-up slide with Q&A.
There's another approach you can be taking. I don't know how we're talking about that. And that is what we would call lightweight formal methods, whereas you don't try to certify, say, the hypervisor for all these grand security properties, but you take a lightweight property, if you will, like what SLAM does for device drivers, and you just try to exercise or validate the code using tools, which we know are successful, which have shown ROI. And in other words, you creep up on the bigger problem by doing something you know you can do. Moreover, the developers around here already have seen the benefits of using these kinds of tools. They creep up pretty fast.
Yep.
And so maybe that's a better way to creep up on it. Meanwhile, you can have a parallel effort in training more and more people who are agreeable to being trained in understanding the more sophisticated notations and logics that the grander plan requires.
Yeah, I think that's a good point for us to go away and think a little more about. Certainly annotation is something I think we do have.
Spec-string, you just say, start with that.
Spec-string is formal methods.
Right.
They call it spec-string instead of pre and post conditions to keep them scared of the wrong developers, right? So
right.
That is, you're not going to get big properties like NSA, but you've got effective tools, and the developers have bought into that, and so has management. So I think that is the thing to push on in a big way, and it would be effective and realistic. Compared to transitions of higher specifications and really having the tools to prove the correspondence with the code and the specs to keep it in sync the way we do with something like spec. So,
and I think if you're going to talk eventually about full-fledged program verification using theorem provers, that kind of training and long-term investment you need for the number of people who can just use it, that's far in the future.
That's
sure.
Right. We know that for our own students, our own experience, using the current state-of-the-art theorem provers, for instance.
Right.
But whereas the lightweight model checkers, for instance, that's just a given now.
You're going back into your advice earlier. Is that?
I'm trying to help them actually.
Was he yelling?
No, I wasn't yelling at them.
No, this is helpful.
This is incredibly helpful. Absolutely.
This is very helpful.
Very good feedback. All of this.
I think it demonstrates that you understand kind of the position we're in.
Yeah.
And
Yes.
we need help from
And
you guys.
I'm saying that this argument to your management might be more palatable. And it's a real one.
Look, so I agree. I think that what that is absolutely the right way to increase your assurance in this piece of software. It is not the right way if you need to check off the I did a formal verification.
Right.
And none of us, and I don't think that's a very important box to check off, given what I think the real reason to do the assurance is because of where I see this in the product life cycle. I don't see this as something you want to get certified so you can sell it to the defense market, because that's not as nearly the kind of market as all the rest of us, and what I think Microsoft believes is going to be enabled by having really trustworthy software. So I think you need to stop selling this as if you're going to build a high assurance a la DoD system, and start selling it as we're going to build something that has the kind of assurance that is needed for our vision that we sell trustworthy computing. And then a lot of these slides are going to change. You're going to be much more definite and measured about what existing tools you're going to apply where, and what it's going to gain you in terms of the assurance for the product.
Okay, that's great.
Yeah, and that's an ongoing dialogue I would definitely love to have with you, because I think a lot of these slides we have put in as things we really think we're doing, and I know it's hard to show that in one slide, but many of these single slides we have a whole deck that drills down on how we're going to apply them. Some of them we don't, and are the areas where we're definitely looking for a lot more feedback, and formal methods is one of those areas where we've, as I say, we've dabbled around a bit trying to get a feel for what the right application is for where we're at.
I don't think with 30 people, I think with 30 people you're going to have a hard time building the system, period, the software. I don't think with 30 people you're going to build the software and come anywhere near all the boxes that I've seen on this list of techniques you're going to apply.
30 people is just the developers, by the way. I have a test team as well, and then that also is test developers. So I'm not sure if you were expecting that with both of them.
Not counting testing, but everything else I would regard as something that a developer is supposed to do analysis. So we have an executive session that should have started about 10 minutes ago.
Okay. Well,
I think it's important for this to come to us and move forward.
So basically, if there are more questions that we can answer right now, I'd also like to figure out how we're going to take this forward with being able to kind of communicate a little more higher bandwidth on some of these issues. Maybe there are no more questions.
Well, I'd like to just congratulate you guys for thinking about this. This is really refreshing, very refreshing.
I appreciate that, Judge.